Okay, this is a discussion on what we call frequency selectivity, or the ability to hear out different frequencies at the same time. So many of us were, let's say, in band in school, or have been to a concert, or have listened to more than one person talk at a time. The ability to do all of those things is reliant on what we call frequency selectivity. Okay. Um, so let's use an orchestra or some kind of instrumental musical performance as an example. When you're sitting there, right, you can hear numerous instruments at the same time, right? You could hear the flutes playing, the saxophone playing, right? You can hear different instruments because they have different frequencies. And the auditory system can process those frequencies separately, or what we call resolve them, meaning that some of those frequencies are resolved in some filters and some of them are resolved in other filters. Now, what do I mean by filters? The auditory system acts as a set of what we call band pass filtering. So if you remember from previous courses, when we talk about band pass filtering, we're talking about a filter that passes only information within a band, frequency band, like this, or this, or this, okay, as opposed to other types of filters. So the auditory system acts as a set of bandpass filters that in the low frequencies are pretty narrow and pretty precise. But as you go higher in frequency, you can see how they start to broaden out, okay? And what that means is, in the normal auditory system, in the low frequency region, we have better what we call harmonic resolvability, meaning one harmonic falls in one filter and another harmonic, the next harmonic, falls in a different filter, meaning you can hear the difference between those, that there's two sounds. In the high frequencies, naturally, in a normal auditory system, you have a broader filtering. It's just a consequence of the cochlear structure. And you have unresolved harmonics where you can't hear the difference. You can't hear these two sounds separately, okay? So that's the normal system. That's how it works for the normal system. What happens with hearing loss is you have reduced frequency selectivity or resolvability, meaning that, all of the auditory filters are broadened. And the broadening of these filters creates the situation where the auditory system can't process as finely as it can hear. Whereas these two sounds would be heard as different, these two harmonics would be heard as different sounds. These two would not, because of the broadening of the auditory filters, okay? That leads to what we call reduced frequency selectivity, okay? And once that occurs, hearing aids can help make sounds more audible, but it can't go back and restore the frequency selectivity that it used to have, right? It can't make this look like this, okay? And that's what we mean by the physiological damage. Once it occurs and you can't change that. You can make sounds more audible, but there's still that physiologic damage. So that's what I tried to go over today. I hope that was a little more clear after you had some time to think about it. But again, we'll mention it again. But those of you in hearing science will get this. We're going to talk about this, so you should be ready for that. All right. Have a good day.